Hi there. This unit is going to be divided into 3 short videos. The first is just going to be an overview of what we're going to cover in this entire chapter. And we're also going to get into an introduction to derivatives and its notation. The second video is going to look at the definition of a derivative and an alternative definition with multiple examples. And the third video will look at graphs of f and its derivative, the function and its derivative, one-sided derivatives, and applications of derivatives. So what I'd like to do right now is kind of step back for a second and think about what we did in the last chapter. In the last chapter, we talked about we talked a lot about finding the slope of a tangent line, okay? We didn't just want to find the tangent line, but we were asked to find the slope of a tangent line. And we found that we couldn't just find the slope of the tangent line easily because we were only given that one point. In order to find slope, you need 2 points. And we're only given 1 point, we were getting a denominator of 0. So what we did was we tried to find the slope by using a secant line. And the secant line, we used a point over to the left over here, and then we used a point to the right over here. And then we found the slope of what that line was going to be. And then what we did was we let our points start to merge and get closer and closer to this point until they actually reached this value here. So it ended up being the tangent line. So we let the secant lines, the points drag in from left and right and get closer and closer. And we used limits to achieve that goal. So let's just summarize exactly what we did. So in summary, we, to find the slope of a tangent line, to a curve, we use limits of the slope of secant lines. So in our last chapter, we talked about how all of these titles all mean the same thing. So if you're asked to find the instant rate of change at a point, or if you're asked to find the slope of a line to a curve, or you wanted to use your difference quotient, this became a very popular concept to use, f of x plus h minus f of x over h, or if you wanted to find the slope of the tangent of a line to the curve as limits of slope of secant lines, these are all the same things. Now, we're going to give this big title. All of these things are basically just what are called differential calculus. Another word for all of these, instead of find the instant rate of change, you're going to say find the derivative. So if you're ever given the term find the derivative, think, oh, that's instant rate of change, or that's slope of a tangent line, or that's the difference quotient formula, or that's the concept where the secant lines approach the tangent line. So that's simply all a derivative is. Okay, so here's an example. We're going to take a function f of x equals 1 over x. Here's our beautiful graph. And then we're going to be asked to find the slope of the tangent line. So in other words, find the derivative at x equals -1, x equals 1, and x equals 2. So we're going to use our difference quotient. For this case, I'm going to find the general formula for the derivative at all points because I have all 3. So I'm not going to substitute in -1 for a at this point. I'm going to get a general formula in terms of a, and then I'm going to substitute at the end. Okay, when I substitute a plus h into 1 over x, I end up with 1 over a plus h, and when I substitute a in, I end up with 1 over a. Now I need to get a common denominator of a over a plus h. So when I do that, the first fraction, I need an a in the numerator, because if the a's cancel, then I'm left with 1 over a plus h. And for the second fraction, I added an a plus h, so I need to add a plus h here, and if I see the a plus h and a plus h would cancel, so I'd be left with 1 over a. And I can't forget that this is all over h. I'm going to stress right now, when you're taking these notes, make sure you don't leave off limits or just leave off h, because it's just a bad habit. So always keep your fraction accurate. All right, so now I'm going to clean up the numerator. So the numerator is going to give me a minus h over a times a plus h. And again, this is all over h. So then I'm going to be looking at the limit as h approaches 0 of negative h over a times a plus h, all divided by h. And I have a fraction with a fraction, so I'm going to make that the limit as h approaches 0 of negative h over a times a plus h times 1 over h. H's cancel. We let h be 0 when we substitute, and I am left with negative 1 over a squared. Now, what we have just found is the slope of the tangent line at all points. So this is the formula that will give us the slope of the tangent line at negative 1, at 1, and 2. We notice that negative 1 over a squared is going to give us a negative slope. And that kind of makes sense, because when I draw my tangent lines in, all of these are always going to be negative. Okay, so when I get slopes here, I should get negative slopes. And we're going to use this formula to plug a in for negative 1, 1, and 2. Okay, so the slope at negative 1 is going to be negative 1 over our a value in this case is going to be negative 1 squared. So that's going to give us a slope of negative 1 over 1, which is negative 1. So if I go up to negative 1, I'm going to have a slope of negative 1, which makes sense. Good. Okay, now if I do at x equals 1, I'm going to get negative 1 over 1 squared, which is also negative 1. So that's going to give me a slope at 1 of negative 1. Yay. And then if I do at 2, at x equals 2, that's going to be a slope of negative 1 over 2 squared, which is negative 1/4. So at 2, I'm going to have a slope of negative 1/4. Okay, so now we're going to get a formal definition of a derivative. This is nothing new. We've been doing it, but let's just formalize it as our definition. Okay, so notation for derivative. We're going to call it y prime. If we just have y with an apostrophe, that's notation for a derivative. You can also have dy of dx. Okay. You can also have df of dx. You can also have the derivative of f of x. You can also have f prime of x. So any of those notations will all just mean find the derivative.